Hello everyone, welcome back. So let's actually try out an example using the dot product. Let's make sure my pen is working. There we go. We can do this. So first off, here's our problem. So we have a little hook right here, and we have a force acting on that hook, which is all well and good. And we want to figure out the angle between that force and the origin. So we have this line connecting us from A to the origin. Try to figure out what the angle between those 2 points is. So, can we do it? Hopefully. I mean, if you can't, then I haven't taught you well. So, let's try it out. So what do? Well, first off, we're going to find that angle. And how are we going to do it? Well, I'm going to move my head out of the way, as always. We're going to find the position vector from the origin to that point. Because that's what we have to figure out first, because what is the line we're trying to project on? Second, we're going to use our equation. It's going to be super easy because it's just an equation. You just plug and chug. As long as you know what that right there is, you can do it. And finally, you're going to figure out what the projection is on that line. Okay, so go try it yourself. See if you can do it. If you can't, then come back and watch the rest of the video. But for now, I'm going to let you pause. So 1, 2, 3. Okay, so you should have paused. You should have gone and tried it for about 5 to 10 minutes. And then come back, and now we'll do it together. So, lots of math just happened here, like, whoa, that was way too fast. It was totally way too fast. So, let's talk about it. First off, how do we get this right here? Well, there's 2 things we can talk about here. One way is to just say, I can figure out where this is at the beginning, and where this is at the end, or where this is at the beginning, give them a position vector for each of those, and then subtract them. That's one way to do it. Technically, that's the origin, so it's just all zeros, and then this would be some point away from the origin, which would be 1, -2, 2. Okay, so we can do that, but probably the easiest way to do any of these kind of problems is just to say, what direction did I go from here? How did I go from there? More or less make this the origin. Whatever place you care about, kind of make that the origin in your mind. And you can say, okay, how far did I go from that point? Well, if I'm looking at just that point, I'm looking at the x direction first. Well, you can see that I went in the negative x direction, 1. Okay. If I'm looking at just the y direction now, you can see I went in the positive y direction, 2. And if we're looking at the z direction, you can see I went in the negative z direction, 2. So, -1, 2, too hard for my pen, -2. And what happened here? Well, this is the magnitude of that position vector. Okay? Because we need both in order to get our unit vector. So, we have the magnitude, we have the vector, we can definitely make a unit vector. Second thing we need to figure out is, well, what is the force? Well, that's given to you. That's not too hard. And then magnitude is just the Pythagorean theorem. But this time we're doing it in a 3-dimensional space, so it's a squared plus b squared plus c squared is equal to d squared. And we take the square root of both sides to get a squared plus b squared plus c squared. Square root is equal to d. Okay. Hopefully that makes sense. If it doesn't, I got more examples for you. I have a lot more information for you to check out if you need it. Okay, then we have to take the dot product. How do we take a dot product? We take first the I component, and we multiply together. Then we take the j components, and we multiply them together. And then we take the k components, and we multiply them together. And then we add each of those. So -1 times -6, right here, that's 6, plus 18, minus 6. Well, that's nice and easy. It's just 18. Be very careful with your units. They actually do matter. Most times, most problems, there's not really anything that's going to be tripping you up, but still, units are important. Okay, and then from this, we have everything we need to figure out what the angle is. So we plug all of this into our calculator. I'm not going to bother to do that because you have a calculator. You can do it if you want to check me. Oh, and seriously, check the numbers because sometimes they're wrong. I mean, I try to go through and catch all the mistakes, but I miss some. And if you find one, I'll give you extra credit. So, try to find my mistakes. The more you help me to make this class better, the more extra credit I'll give you. Okay, So you do that and you find out it's 57.67 degrees, which just visually looks right. These are not always drawn to scale, but for the most part, it should look right. Okay. So that's one thing, but now we gotta find the projection of this line on this line. So it's gonna be kind of like if I make a right angle right here, it's gonna be this component. Now, how do we do that? We use our nice little equation where we simply take the dot product of the force vector and our unit vector for this line. Unit vector for that line, not unit vector for the horse, okay? How do we get the unit vector? We simply take the position vector and we divide it by the magnitude. That's what you see right here. That's where that 3 is coming from. We got the 3 earlier. We take our dot product, we get 6 kilonewtons. And then we simply, if we want to, we can multiply the 6 kilonewtons by the unit vector to then have a force vector. That'll tell us the component, the vector components of the force vector along that line. Or in this case, we only care about the magnitude, and so all we care about is the 6 kilonewtons. Okay, so we will stop there, and next one, as you can see, there's going to be another example for us to try out. So I hope this helps you. I know this goes kind of quickly, a lot faster than you can write, but it's a video, so stop, rewind, check it out, see if it helps you. Thanks for watching. Bye-bye.